Now, the final part of this week's lecture is on the Miller and Modigliani model. What they are actually trying to answer is what's the optimal capital structure for a company? So what's the best debt to equity ratio? And they look at three different cases in order to come up with this model or to come up with the answer. Case one is they assume there's no taxes and bankruptcy is not possible. Case two is they say taxes exist, but bankruptcy is still not possible. And case three is the only realistic one, and it says taxes exist and bankruptcy is possible. Now, it's sort of a weird scenario, but we basically end lecture 5 at this point. We do case 1 and 2. And what we're trying to do is we're trying to figure out when you maximize the value. And I'll give you two terms. So there's proposition 1 and proposition 2. And the way I find it's easiest to think about this is proposition 1 is the value of the firm. And what we want to do with this is we want to maximize it. And proposition 2 is the weighted average cost of capital. And what we want to do is minimize the weighted average cost of capital. So both of these two things will happen at the same point if you find the optimal capital structure. So for example, case 1, no taxes, no bankruptcy. Proposition 1 would be how are you maximizing the value of the firm, and proposition 2 would be how are you minimizing the cost of capital. The conclusions that they come to in these cases are that capital structure is not relevant in case 1. Okay, so what that means is there is no optimal debt to equity ratio. Sounds odd. It says the value of the firm will never change, the cost of capital will never change, but they've made some very odd assumptions. Okay, no taxes, no bankruptcy. Now, what about case 2? If you have taxes, you're getting a tax break on the interest. So you get a refund, essentially, for deducting the interest. And it's impossible to go bankrupt. So you can basically just keep adding debt. So the optimal capital structure in this case is to maximize debt. And although this is not part of this chapter, I'll just go over case 3 because it's all part of the same model. That's the realistic one. What's the optimal structure? This one says that each company has a unique capital structure, or a unique optimal capital structure. So unlike case 1 where it says it makes no difference, this one says it does make a difference, but it's different for each company and there's not really any formulas for it. There are formulas for the first two, and I'm going to write those out here. The basic formula, we're going to say that let's do it this way. So case 1, the value of a levered firm is equal to the value of an unlevered firm. So a levered firm is a firm with any debt, even $1. An unlevered firm is no debt. Okay, which is consistent with their conclusion that the value doesn't change whether you add debt or not. It's the same. Not really realistic, but that is what they conclude. So what's the value of this firm? In this case, all of the examples that they look at is EBIT over RU, the cost of unlevered equity. So why is it EBIT over that? It is assuming that this is forever. So essentially it's a perpetuity. And that's just because that makes it easier to solve. So if you say the value of a firm is its EBIT divided by its cost of equity, that's the value of the firm. And whether it's levered or unlevered, it's the same value in this case. The cost of equity, the levered cost of equity, is equal to the following. Debt over equity times RU minus RD. And so this is the levered cost of equity. So if you have any debt, that's your cost of equity. RU is the unlevered cost of equity. Okay, D and E are debt and equity, and RD is the cost of debt. Now notice we didn't put 1 minus a tax rate to assume the deductibility of debt, because in this case we're assuming there is no taxes. And the formulas for case 2 are as follows. The value of a levered firm is the same as the value of an unlevered firm plus debt times the tax rate. Okay, and this is called the tax shield. So it is not, key thing here is not debt times the interest rate times the tax rate, because that would be 1 year of savings. This is all of the savings brought together in 1 year, or today's value. So kind of like when we did the present value of all the CCA savings. So what it's saying is the firm goes up in value with all the savings from debt. And it keeps going up because you can't go bankrupt. So you can see, just looking at that formula, how would you maximize the value of a levered firm? You would maximize the debt portion. And the formula for the levered cost of equity is very similar to the one we just did. It's the unlevered cost of equity plus debt over equity. Now we put the 1 minus the tax rate times RU minus RD. Okay, so it's the same formula. Technically, you could use this one and the first one as well and just put tax rate as 0, and then you end up with the formula that we had for the first one. So we'll end it there for week 5, and that's everything that's on the midterm. And then next class, when we do case 3, that'll be part of the final exam.